मित्रांनो, गेल्या वेळेस लेक्चरमध्ये आपण कोएक्सियल लेन्स सिस्टीम बघितली आणि त्याच्यासाठी केस बघितली की ऑब्जेक्ट सिच्युएटेड ॲट इन्फायनिटी, and for that we have been discussed about its cardinal points, where that cardinal points to be situated. Again, we have been calculated the equivalent focal length of it. Now we will proceed further. We will learn now the important part of the chapter, that is eyepieces, and in which we having two eyepieces to learn as per the syllabus, that is Huygens eyepiece and Ramsden's eyepiece. See, eyepiece is very important for spectroscopy, or in optics we can say here. Whenever we are doing any experiment, we are going to observe anything. At that time, we are using the instruments like a telescope. Then, if we are interested to observe the spectrum, at that time we have to use the spectrometer. And if we want to do the experiment again, then again laser and all these things. But what about its eyepieces? Then we have to study the construction, working, its cardinal points, how it are constructed. Here today we will see about the Huygens eyepiece. See, the Huygens eyepiece consists of two coaxial plano-convex lenses, which having a focal length in the ratio that is 3:1, means if a field lens having a focal length 3f, then eye lens having a focal length f, and the distance between these two lenses means that what should be its distance, then the difference between focal lengths of these two lenses, that will be the distance to kept, that is here 3f minus f is 2f, is the distance between these two lenses, means that the difference in their focal lengths. See, these this eyepiece is free from chromatic as well as spherical aberration. See friends, aberration is a term. It is nothing but the defect, we can say, in optics. Aberration, then astigmatism, coma, these are the nothing but the defects. And chromatic as well as spherical aberration is not present here, means that this eyepiece is free from these types of defects, and it satisfies the two conditions simultaneously. Which are the two conditions? See, for condition of achromatism, and here again condition for minimal spherical aberration. Now, for if any eyepiece is free from the chromatic aberration, means it should be follow the condition, that is D equals to F1 plus F2 by 2. And in the case of hygiene eyepiece, what is the F1? As we have been seeing, the F1 means focal length of first lens is 3F, and focal length of another lens, that is of the eye lens, it is F, and therefore D equals to 3F plus F by 2 and D equals to 2F. And if this D equal to 2F, then if D equals to 2F, then this is the distance between the field length and the eye length, and hence the hygiene eyepiece is free from chromatic aberration. Now another condition due to which it is a minimum spherical aberration, the lens here, the distance between the two lenses for minimum spherical aberration is D equals to F1 minus F2. Again here F1 is a 3F and F2 means focal length of second lens is F, and therefore it is nothing but that is 2F, and this D equals to 2F. This is the distance between the field length and eye length in hygiene eyepiece. Hence, hygiene eyepiece again free from spherical aberration. And see, friends, working how this hygiene eyepiece works. See, if we having a telescope and we are going to mount this eyepiece, like Ramsden's eyepiece, when the eyepiece is adjusted for the normal vision, then the final image formed by it is at infinity, means it having the infinite distance, and the image formed by the lens should lie in the first focal plane of the eye lens. Means that he is saying that at a distance F to the left of the eye lens, or at a distance F to the right of the field lens, as the distance between the eye and field lens is 2F. Means that, see here, for getting the idea of working, it is important again how the conditions for minimum chromatic aberration and spherical aberration. Therefore, by keeping in the mind that conditions, the focal length of the field lens should be 3 times the focal length of the eye lens, and the distance between them should be equal to twice the focal length of the eye lens. And see, hygiene's eyepiece is constructed on this important principle only, and therefore, to if we have been keeping in mind these things, then see in the diagram you can see that, see, this is the diagram, and in this diagram this L1 is the first lens, this L2 another lens, L2 is nothing but the eye lens, this is the field lens, and distance between the position of equivalent focal length, that is a phi F. and distance between these two lanes is 2f. See in this description a distance f to the left of the eye lens. Yes, this is the image I. Left of the eye lens at f to the right of the field lens as the distance between eye and field lens is 2f. The inverted image I1, see this is a inverted image, and that inverted image, what he says, the inverted image I1 of a distance object formed by objective acts as an object for the field lens, and this gives a rise to a virtual image I2. Means that this image, inverted image, acts object for the field lens, for this field lens, and this gives rise to a virtual image I2. I2 in turns, this is a virtual I, and I2 in turn serves as an object for the eye lens, therefore it must be at a distance equal to focal length f from the eye lens to make a final image at infinity. This final image we get at infinity. For field lens u, if u is the distance of I1, u is the distance from I1 from the field lens, then from lens formula, as we know that lens formula I upon v minus I upon u equals to 1 by f, and if v is a f and f is 3f, then u equals to 3 by 2f, and the positive sign indicates that image I1 formed by field lens as well as the image I2 formed by objective lies on the same side, and it means that the field lens focus the rays at I2 which otherwise would be focused at I1 by the objective, and the rays coming from I2 emerge from the eye lens as a parallel beam. Here this eye rays coming from I2 emerge as a parallel beam. Then what about its equivalent focal length? See, for the equivalent focal length, if we having a f is the capital F is the equivalent focal length of the eyepiece, then it is given by 1 by f equals to 1 by f1 plus 1 by f2 minus d upon f1 into f2. As if we are putting the values of f1, that is nothing but the 3f, and f2 equals to f, and d equals to 2f. Here d equals to 2f, then the equivalent focal length, that is nothing but the f1, it should be a 3f, f2 equals to f, and d equals to 2f. In this way, in other words, we can say that the equivalent lens is at a distance 3f minus 2f equal to f behind the eye lens. Means at a distance f behind the eye lens, it should at that distance there is a equivalent focal length. Then what about the position of cross wires? Again, see now the image I1 is in diagram we can say the image I1 I and I1. I and I1 is at a distance of f by 2 from the I lens, or 3f by 2, see here, 3f by 2 from the field length, 3f by 2, this I1, and hence for the field length u equals to minus of 3f by 2, minus of 3f by 2. That is, by the calculations for the cross wires, we can take, we having a formula that is 1 by u plus 1 by v equals to 1 by f. And see, 1 by u is nothing but minus 2 by 3f plus 1 by v equals to 1 by 3f, and v equals to f. That is, the I1 lies midway. I1 lies midway between the two lenses. I1 lies between the midway between the two lenses, and so fixes the position of the cross wires or scale. See here, the image formed by the objective lens. The image formed, this is a field lens and eye lens. The image formed by the objective lies behind the field lens, and therefore this eyepiece is also called as a negative eyepiece. Keep in mind this statement. This is a field lens, this is a eye lens, and the image formed by the objective lies behind the field lens, lies behind the field lens, and lies behind the field lens. Therefore this eyepiece is known as a negative eyepiece. In instruments using Huygens eyepiece, scale is not used. Scale is not used when magnification is low. This is important points to keep in mind. See, again we have to see the about its cardinal points also. For that cardinal points, this is nothing but the diagram for getting the cardinal points, in which this is the first focal plane, another focal plane, first focal point, another focal point. These are the nodal points and all these things. This is nothing but again field lens, eye lens. See now what he says about the focal points. Therefore, the distance of first focal point f1 from the field lens L1 is given by, this is a formula, that is beta equals to minus of f into minus of f in bracket 1 minus b upon f2, and putting the values minus of f1 minus 2f by f, and beta equals to, beta 1 equals to 3 by 2f, and here again the positive sign indicates the first focal point f1 lies at a distance 3f by 2. In the diagram you can see 3f by 2, the f1 is 3f by 2, this f1, is a distance 3f by 2 from this field length. And again, what about the second focal point? Second focal point again half f, half f, again here positive sign here, therefore the second focal point lies at a distance f by 2 to the right of length L2, length L2 f by 2, this is a length f2, and right of this is a point f by 2 at a distance f by 2. Then again see what is the position of principal points. Again we have been seeing these focal points, and these are the principal points here. What he says for the principal point, the first principal point here h1, he has been given the name for the first principal point. In last lecture we have been nomenclatured it as P1 also. P1 from the H1 from the field length L1, and is given by alpha equals to B into F, is a multiplication sign between this and divided by F2, and by putting the values alpha 1 equals to positive 3f. Again here the positive sign indicates first principal point H1 lies at a distance of 3f to the right of field length L1. Here see here Pf, this is the field length, this is the first H1. H1 we can say it is at the first principal point. And again for the second principal point, what he says that a minus of f, and again see here the negative sign indicates the second principal point h2, or we can say p2 at a distance left of the islands L2, left of the islands L2, left of the islands. Where is the islands? This is the islands. Left of the islands, this is the left of the islands, and at a distance f, this is the distance. This is taken in that calculation as a negative because it is left to the islands. Here again, what about the nodal points? See, as the medium on the other side of the eyepiece is the same, that is the ear medium, and the nodal points N1, this is N1 and N2, coincides with the principal points H1 and H2. Keep in mind this H1 and H2 can be nomenclatured as P1 and P2, and respectively the position of cardinal points for Huygens eyepiece can be plotted in this way. This is a diagram or the diagram for the cardinal points, how it can be located. Now position of crosswire we have been already discussed previously, and see what are the merits of this eyepiece. We should know the Huygens eyepiece is fully free from chromatic aberration. Keep in mind once again, this Huygens eyepiece is completely free from the chromatic aberration because the distance between the lenses, distance between these lenses, two lenses, that is field length and eye length, the distance between these two lenses, this is a field lens, this is eye lens, is equal to the half the sum of their focal lengths. Is equal to the half the sum of their focal lengths. Means what is the sum of their focal lengths? Sum of their focal lengths 3:1 means 3 plus 1 equal to 4, and therefore they are kept as 2f, and this is the difference between them, and therefore the chromatic aberration in Huygens eyepiece is not there. What about the spherical aberration? The spherical aberration is also minimum because the distance between the two lenses, is equal to the difference of their focal lengths. Again, what is the difference between their focal lengths? 3f and f. 3 minus 1f equals to 2f, and this is the 2f. Distance between the field lengths and eye lengths is 2f, and therefore spherical aberration is not there. Again, the field of view of this eyepiece is smaller than that of a Ramsden's eyepiece. This is one of the point to keep in mind for our preparation for the point of view of examination, and as we should have a knowledge about this, and by which here today we are going to finish the Huygens eyepiece, and next time we will see another eyepiece that is nothing but the Ramsden's eyepiece. Today we will take a pause for coming lecture. Thank you very much.